Welcome back. Continuing on the precise definition of limit, let f be a function defined on some interval negative infinity to a. Notice this is an open interval. So we are looking at the left hand piece of your graph. Then limit x approaching negative infinity of fx is L, means that for every epsilon greater than 0, there is a corresponding number n such that if x is less than n, then absolute value fx minus L is less than epsilon. So let me explain this once again. What this means is, for large enough x to the left, x less than capital N, okay? So going far away to the left, if x were far away to the left, then the distance between fx and L is less than epsilon, okay? So for any, however small epsilon you choose, if you go far away to the left, then the distance between fx and L can be made as small as possible, as small as needed. So this is limit x approaching negative infinity, and in our previous video we saw the definition of limit x approaching positive infinity. So these are precise definitions of limit at infinity. So from here, that is let until epsilon, this epsilon, okay? You have to memorize. This is for limit x approaching infinity fx. On the other hand, this is for limit x approaching negative infinity of fx. So again, starting from L, let until this epsilon. How are these precise definitions to be implemented? Here's an example from the textbook. You want to prove that limit x approaching infinity of 1 over x is 0. So we saw by experiment, that is, we plugged in various values of x and saw that this limit was 0. But here is a precise definition. Here is an approach using precise definition. Given epsilon greater than 0, so take any number greater than 0. You want to find capital N such that if x were large enough, then the distance between 1 over x and 0, that's your limit, is less than epsilon. Well, let's understand what this means. This means absolute value 1 over x is less than epsilon. Because x is positive, you see we are taking right hand limit to the infinity. You don't need absolute value. So 1 over x is less than epsilon. So cross multiplying, this gives me x is greater than 1 over epsilon. Okay, so that n becomes, so that capital N becomes 1 over epsilon. If x is greater than 1 over epsilon, then absolute value 1 over x is less than epsilon. Okay, that's how you find an n. So n equals 1 over epsilon. If x is greater than n, then absolute value 1 over x minus 0 is less than epsilon. Therefore, by definition 5, you get the result you need. You can see the graphs. This is 1 over x. Suppose epsilon is 1. When n equals 1, after 1, the graph is underneath the height of x, epsilon equals 1. If epsilon equals 0.2, just draw that. Look, n equals 5. How did that 5 come about? 1 over 0.2 is 5. 1 divided by 0.2 is 5. After that, the graph falls within the range, and likewise, okay? Now, note that an infinite limit at infinity can be defined as follows. Here is a geometric illustration. Well, as x approaches infinity, your graph is also approaching infinity. That is very much okay. Okay, which brings us to the last definition, precise definition. Let f be a function defined on some interval, open interval a to infinity. Then limit x approaching infinity fx is infinity, means for every positive number m, there is a corresponding positive number n, such that if x is greater than n, then fx is greater than capital M. So this is what it means to say fx keeps growing large, right? Similar definitions apply when the symbol infinity is replaced by negative infinity. In this case, what would you say? For every negative number m, there is a corresponding negative number n, such that if x is to the left of n, then fx is to the left of capital M. So wherever you see greater than, you would become less than. Wherever you see positive, you would make it negative. That's how you would get precise definition for limit x approaching negative infinity of fx equals negative infinity, and so on. All right. All right then. So this completes all the lectures for section 3-4. My next lectures will go through problems from your web work on section 3-4. Until then.